Are we finished working? Everybody, are we finished working?
Yeah.
Yes.
Yeah.
All right, so you're gonna share what you have, tell us how you got it, then the others will share.
All right. Good afternoon, everyone. Who do we have here today? Apart from David, that is.
Good afternoon.
Okay, so I saw that I heard you in the background there.
And Diane.
Diane.
Oh, no, it's Sabina.
Sabina, that you? Hey, how you doing? Jeffa, come on, hold up your head. All right, what I got? What I did was we're summing 1 to 1,000. Yeah. So it's 1 plus 2 plus 3 all the way up to 1,000.
We can't see what's going on the screen.
Oh no. Yes, eventually. Okay, all right. What I did was lay out the numbers, sum all of them 1 to 1,000 in one line. And in the line below, immediately below, I did it in reverse. 1,000 plus 999 plus all the way down to 1. Then I sum both lines separately. Yeah, so I'll have 1,001 plus 1,001 all the way up to, so that's 1,001 1,000 times. Yes? But this...
Davey, you wrote 1,000.
I did what?
For the second 1,001, you wrote 1,000.
Yes. Okay.
For the second, no, at the bottom. It's supposed to be 1,001.
Right. Okay. It's 1,001. It's 1,001 1,000 times. But this, the third way, this sum is equal to twice 1 to 1,000. So the sum of one of these lines would be a half times 1,000 times 1,001, which is equal to 500,500. And that's 50,500.
Any other method? Any other method? Can you explain to us why this method works, Davey?
Why it works?
Yeah. Or why you use it?
Why do I use this method? I don't know, it just works.
Because it works.
Intuitive, I guess.
All right.
It's kind of intuitive.
Any other method?
This is a.
I did something similar but a bit different. I created an equation. Can I continue?
Go right ahead, I'm writing.
Okay, so I have, for example, my equation would be the sum, all right, is equal to n multiplied by a plus b.
A plus b.
Plus bracket divided by 2. So since n is 1,000, right? And n is 1,000 multiplied by a would be the first term, which is the first number, which is number 1, numeral 1, and b. So you have 1 plus, and where you have b, you're going to put 1,000, which is the last number.
Right.
All right, divided by 2. So I'm going to simplify. As you know, the sum of 1,000 multiplied by 1,001 is equal to 1001000, like you had it there, right?
Right.
And then I divided by 2, and I got the 500,500, which is 500,500. That's how I came across my number, my answer.
Good job. Any other method?
My method boils down to what Davy ended up with. However, I just took the 1,000 times the next number, which is after it, since it's a series of numbers. So I took 1,000 times 1,001, and I just found the average of the two. Instead of adding the way Davy went on adding 1,000 to all the other numbers in the reverse order, I just started with 1,000 times 1,001. I found the average, and I ended up with 500,500.
Very good. Thank you, David. All right. Thank you, guys. Okay. So your test is on Thursday. It's finally here. And you have 4 questions, 2 hours, 42 questions, and you're asked to answer all questions. All right?
What's the duration, Miss?
2 hours. So it's starting from, I think you're 1 hour ahead of us, right?
I think so, yes.
Okay, so it's starting from 3 until 5 for you guys, but from 2 to 4 for Mona. All right, so the rest of those of you who are staying at home, I hope we realize that on Thursday we need to go to our site.
Yes, we know.
Yes, we do.
Okay, just checking. All right, do you want
Do we have a guideline, Miss, in terms of what is expected, topics and so on?
For what?
A guideline as to the format of the exam, topics. I don't know, I'm new to this, so I need to do a bit of studying.
Okay, so all I can tell you is that you have 4 questions. 1 question on one of the topics that we've done throughout the course. That's it. And it's all methodology questions. So how would you do this? How would you guide students to do that? Basically. If I tell you anything more, basically I'll tell you what is on the test. So, right. So that's basically it. I mean, we know that we've been looking at the C6 syllabus and correcting some of the errors and going through how we would approach these topics. That's it. I can't pin it down any more. We haven't really dived into the CAPE syllabus. So, nothing from CAPE would be on it. So it's really the C6 syllabus we'll be looking at, and the questions are not really for you to work out anything, but how would you teach so and so? How would you put across this idea? And it's nothing that you haven't seen in class. So if you were paying attention and jotting down little things, I don't think it's any massive study in either. Just apply what you learn in class. Okay. Anything else before we move on? No? Are you hearing me, everybody?
Yes, we hear
Yes,
it.
I am.
All right. All right, so today I have to leave at 5. I'm trying to get out of here by 5. I have something to do. So I hope you guys are not grossly disappointed.
No, we're not. That is fine.
Thank you for the break.
Okay. I have to leave. I have to leave out. Anyhow, we have 2 things that I want us to cover before we go, though. And one thing is this: I want you to think about if you need to teach variance, how would you go about doing that? That's the first thing we're going to think about. And we're going to do just kind of recap a little bit. So I'm going to give you some topics. I'm going to ask to write the concepts and how you'll approach it. So like things that we've been doing in class, I can focus you a little bit. All right? Okay? So it's for you, it's like a revision, like not telling you exactly what will be on the paper, but it's like zooming you in on some things. Okay?
Okay.
All right.
Okay.
So first thing you're going to do is you're going to know how would you teach variance? If you need to teach variance, how would you introduce it and how would you go about developing the idea of variance? Okay, I'll give you some time to put your thoughts together. No. No, it is very good. No, what I mean is that I know that because my Alright, are we finished working? No, it's not that bad. Trust me. Are we finished working?
Yes.
Yes, we are.
All right, who wants to go first? Come, Ingrid, come on, guys on the board. Hey guys. I'm not seeing anybody. I know that Jeffrey is it. All right, Jeffrey, do you want to go first?
That's too high. We're not seeing.
Oh, okay. Can we fix the camera?
No, it's okay. I just do it though.
Oh, okay.
You're sharing the screen, so you're on the other camera, I guess.
Miss McArthy, let somebody else go first.
Who wants to go first?
It's too high. We're not looking at the camera. You're looking at for reference. Lower.
Still can't see?
Okay, now it's better. Okay,
we can
the
see, we
camera.
can see now.
It's okay.
Your Zoom is a bit too close.
Don't worry. We're ready now.
It's too, the Zoom is too huge.
Zoom too close.
Okay.
The problem wasn't with zooming, it was just with the angle of the camera.
This is too. No, this is too big.
Is that okay? Is that okay now?
Okay for me, I don't know about for them. Who's going first?
You're going first.
All right, here's what we came up with. We thought we'd use the classroom to introduce the idea of bearings. So we choose, for example, students in the center column, center row. So in here we have James or Jamie, Bob, and Jim. Somebody else. It's you, whomever. Right. And then what we said, we possibly look at, we start off by pointing out to them that everybody's looking towards the front of the room. So that gives them a reference point for direction. Okay? So we're starting with everybody looking towards the front of the room. And if Jamie wanted to look at, this is Jamie. Okay, I just changed all these names. Okay, if Jamie wanted to look at Bob, he would most likely turn his head through 90 degrees to look at Bob. Okay? So then they could get the idea that the degree measure from Jamie to Bob would be 90 degrees before we actually introduce what a bearing is. Then if you wanted to look at Angie, he could also turn 90 degrees, but that would be in the opposite direction. Okay? So maybe we use that to bring in the idea that direction is important. We have to know which way Jamie is going to turn his head in order to look at everybody, at each person that he needs to look at. So he needs to look at Bob, 90 degrees, direction is clockwise. He needs to look at Angie. If he's maintaining the same clockwise direction, he would go through 270. If he needed to look at Shelley, he would go through 180 and so on. So therefore, they begin to get the idea of looking in a particular direction and turning to look at the person that they want to look at through a particular degree measure. Having done that now, so that they begin to understand where the direction is important, we possibly point out to them that the idea of measuring with a particular, measuring angular direction with a particular direction taken into consideration is basically called a bearing. So we bring them to know that the bearing is measured from the north clockwise, and that is stated with 3 figures, 3 digits. Then we move from here to a more something like a map to help them understand what we're doing. I don't know. Any other idea?
I can try. Anya here.
Go, Anya.
I would use, well, okay, in physics and science, we use compasses for magnetism. So we have a lot of tiny compasses. So I could probably bring those compasses for the students, and then they can realize that a standard compass only has north. It only has labeled north, but the more advanced one have everything else. But then I would ask the students, like, what is a compass used for? And then from geography, they should know that compasses are used for them to know directions. So then I asked them, so how do we use the compass to know directions? And most of them will say that the compass points north. And then from there, I would tell them, so if the compass always points north, then how do we find east? How do we find south? How do we find west? And then from from discussions, they can determine that east would be 90 degrees because it's assumed that they have the prerequisite knowledge of angles. So then I could translate that on the board for them, because it would be kind of difficult for them to see the actual compass where north is and then translate it to something else. So then on a map, the cardinal points are usually put like how Ingrid drew it a while ago. So then from that, they could see that if an explorer has a compass, from north for him to go east, he knows he has to make a 90-degree turn in the clockwise direction. So we put in clockwise direction. So then I would tell them, if we always have to emphasize that he turns in the clockwise direction, what angle would south be? what angle would west be, and then they would come up with 90, 270, and 90, 180, and 270. And then I would introduce the definition of bearings. Bearings is used to give directions with north as the reference point and the angle that is rotated in the clockwise direction. And then also I will introduce to them that bearings are always written with 3 digits and stuff like that. And then I would ask them, like in the class, to probably identify either where a door is or a window is, with me being the reference point. So I would tell them that if I am standing up here and this is north, then if you can estimate what angle would the window be, or put a student to stand up somewhere, what angle, what direction do I have to move so I could reach the student, and give it to me in terms of a bearing, meaning referring from the north and rotating. And then each answer they give, I'll translate it to a diagram. So then from that, we move to me drawing a diagram on the board with 2 reference points and asking students to describe in terms of bearings, where is one point from the other, and then move to the reverse for me to give them a description and to draw the simple bearing. And that's it.
Very good. Very good. That's actually that method. For me, that method where you start a point and ask students to estimate the bearings there. That's my first thing. Can we use a map? Is there any way we could use a map to teach bearings?
Yes, you can doing the same thing. You identify 2 points and you have them estimate the bearing.
Okay. Anybody else? Anything else? Did we come up with anything else? Jeffrey, do you want to go now?
Anya had a similar explanation. I had 2 students standing at different points instead of a window and myself. I had 2 students and we were going to estimate the bearings.
That's the thing. The main idea. So who else is with us? Tasha, are you there?
I'm there.
Do you want to share?
That's okay.
Carlene, are you with us?
Yes, she is with you.
Do you want to share?
Well, I guess much of what I would have said is covered already, because when Ingrid spoke, she didn't talk about like the 3 digits, that bearings must be in 3 digits and so on. But Anya covered all of that, and I guess that's basically it. I think it's covered.
Yeah. All right. Anybody else? All right. Why is there measured with 3 digits? Why is it written with 3 digits? Huh? Convention. Yes, there are some things in math that are conventional, and we just need to understand. So when our students ask us, some of them will ask you, that means why is that we use 3 digits? It's just convention. Many things in math are just conventions. So we just have to understand the things that are convention. Even when we do bombast and say what you do first, that's convention. So a lot of the things that we do, they're just sort of convention.
I think it's also good because it helps you know whether you're speaking of a bearing or such a bearing.
What's a bearing? Is an angle.
Yeah, but in a specific. Likewise.
Yes, it's a specific, but really, when you think about it, it's really is a certain turn from a north direction. Yes, yeah. But it's at the end of the day, it's just an angle. It really is an angle. Because if I'm looking, I might be going in a different direction. I'm measuring from a particular direction, but it's still an angle. So that's the relation we want to create, the bearing is an angle. Because some of them, they still not get it like size an angle gets it. I don't know, like, if it's what's the bearings of blah, like either all 20 centimeters or, you know, I don't know if you've seen that anywhere. So I guess that some of them, I'm not getting that some of them get it as an angle rather than a length or something else that they might have in mind. Are we clear with what I just said? Are we clear?
Yes, we are.
Yes.
Do you see that some of you students
Yes.
it's really is an angle? Bearings is really an angle?
Yes,
Because,
yes, it is.
because I've seen where students give answer like 20 centimeters or kilometers or whatever. They give a distance rather than an angle. So one of the main things we have to get them to recognize that it's an angle. And this is conventional why we use 3 digits.
McArthy, another thing I use in my class to make sure they understand it, I tell them if they tell you a bearing of B from A, the from is your starting point, and of is where you going. So I always tell them look for the word from to start.
That's very good, very good. I think that please listen everybody, one of the challenges with students understanding bearings is the reading the sentences and understanding it. Do you find that the students are not interpreting the questions properly? Like, as you were explaining, on the bearings from A to 60 degrees. I don't understand why they're not interpreting the question properly. I don't know if I get it. Huh? I don't know if it's an English thing, but students tend not. So probably we need to kind of break it down a little bit for them so that it help them go through it. What do we mean by that? That was a good point, Jeffrey. Anything else? And
thank you.
do you see that when they're also sketching the diagram? What do you know about their sketches? And this is the thing that they do for all diagrams that they need to sketch. What do you know about the sketches? What other thing you know about the sketches? I would pay attention if I were you.
When they have to estimate angles and lengths, it's a problem for them. It's like they don't keep it in mind. For example, if they tell them a bearing is probably 110, you will see them drawing an acute angle, and then the whole diagram is off, because even though it's a sketch, you still have to put it in the relative position it should be. So then when it comes to them estimating certain lengths, for example, if they tell them 110, 60 kilometers, and then something else is 5 kilometers, you would find the 60 and the 5 kilometers within the same length. So then from that get-go, the diagram is off. So then when the next question says to find a bearing of something to something else, they'll be like, but how am I supposed to do that? Because I mean, the point is just there, or something like that. So when it comes to sketching, yes, they know it's a sketch, not an actual diagram, but they miss the fact that they still have to consider the sizes of the angles and the lengths.
It should be somewhat realistic. Even though it's a sketch, it should be somewhat realistic. So for example, as you've said it perfectly, if I'm drawing a 120 degrees angle, it should never be an acute angle. But I've seen the students, they've done this so many times. And if you need to sketch something, and they'll do something like this, and tell that this is 10 centimeters, and this is 3 centimeters. You know what I mean? So even, I've never seen students do things like this. So even the idea that this 3 centimeters in relation to this 10 centimeters, it should be obvious that this one is smaller than this, and even the length in terms of estimation should be somewhat realistic. And that's a very important point, because if the diagrams are drawn properly, then the question will be automatically wrong. So even though they have all the prerequisites, they might understand, well, I don't even understand in angles, but they have some awareness of angles, because if they truly understood angles, then if you say sketch a 120-degree angle, they would definitely not sketch an acute angle. But then it comes back down to how we teach angles.
It may also be the importance that they place on drawing a diagram that's realistic. Because some students may sketch the diagram that doesn't look like what it should, but they can work the problem and get it right.
Yeah, but
maybe as teachers, we need to ensure that we help them to see that it's important to draw the diagram professionally. Maybe they just don't do it because they don't see it as important.
That might be a good point too, but it's something that even when we're doing construction and we have them sketch different angles, you need to construct a 60-degree angle, sketch this angle. And when you look at what they sketch, you're really like, this is really, seriously? So probably we need to focus on them having a visual representation in their minds as to when I'm sketching, it must be somewhat realistic. It must be. All right.
And it also helps them when they're solving the problems, and like if they're going wrong somewhere. So like if they're getting an angle that's 110, and then they're seeing from their sketch diagram it's something that's supposed to be like about 90, then it could help them if they're going wrong. So then they would realize their mistakes. But then again, it's dependent on if they sketch it properly, because many times like students just ask me, like if I make a mistake working something for them, and I'll be like, no, this is wrong. And they're like, but miss, how do you know that it's wrong and you don't even reach the answer yet? I tell them, because from my sketch, it's impossible for that to be the answer. Then it's like this little thing. And then they marvel at how can somebody know, because some students are like that, they can know when they're going wrong way before they find the final answer. So they marvel at that. How can a child know that they're wrong or right when they're doing math? So all these things, these little things, we take it for granted, but it really helps them in the long run.
That's true, because the truth is, students, before we start working on a math problem, we should have a basic idea in our minds as to what the answer possibly look like and what can't be the answer. Then they should have started to kind of develop that skill as a skill, that we have to teach them. We have to teach them that skill of estimating. All right, if I'm adding 10 and 5, you need to have an idea that it must fall somewhere there in the teens, or you know what I mean? So that's a simple example, but our students need to get an idea of what the answer should look like. So as you rightly said, Anya, when they're off, they should be able to readily identify. Yeah. All right. How is it that bearings can be applied to your everyday life? In terms of who uses it, what career?
Pilots, people at the airport, the towers, they usually interpret directions in terms of bearings. Cruise ships to captains and stuff like that.
Okay. So one of the things that I'm trying to get us to, like, you remember when we're talking about linear program, we talk about persons who want to get into the business and to maximize profit. This is something that they would want to use. One of the things that I really want us to walk away with is that even when we are going to teach certain topics, we want to be able to say, if you want to become an X or Y, if you're interested in this career, pay attention. Because the truth is, then we start to understand, like, oh, we really use this, and if I want to do this, I have to pay attention. I have to understand this topic very well. I don't know if it makes sense to you, but there's this utility of the subject. It's very important. So they don't say, okay, I'm just learning math just like that. But we always have to try to apply to something or to some work, to such job, because what's the purpose of learning something? It is really for you, for the job market, for you to be able to function in society properly and to get good jobs and make a contribution. So it's not just learning to pass the CXC exam as most of our students think, but we're preparing them for that. We're preparing them for careers. And so we need to start teaching them like this, okay? Applications. And even the STEM-related math, we need to start giving them activities so they can start, yes, let them build bridges too. Let them do things that say they're applying the math. I see you trying to say something, David.
And also on their phones, Ms. McArthy, the smartphones have compasses, so you could also, and it tells you bearings actually, because it starts from 0 being north and it goes all the way around. So then you could use the phones, you could make them use the compass on their phone, on their smartphone, because the majority of them have smartphones anyway. And if they don't, they can always share with someone else. And then in the activity where I was saying for them to find like the windows or another student, they could literally use their smartphones with the compass to find it, because it gives you a bearing. It's not in the 3 digits, but it does give you a clockwise angle from the north.
Do you know this one?
It's too high. The camera is, we're not seeing it.
Do you know this word? Are you familiar with this word?
I'm familiar with the
You know, we call it void. Yes. It is. It's bring your own device. Yes, it's something that we use in our math classes. where we get our students to whatever they have, the tablet, their cell phones, their laptops, we allow them to bring it one day, and we plan our lessons to incorporate them. I think it's kind of useless for us to keep saying, don't bring your phones to school because they cannot bring it anyhow. But instead of having them using it just for WhatsApp, we can show them how to use it for learning purposes. That was a good idea, using the compass on your smartphone, you know, having them do different things on their phone, learning different things on their phone. Bring your own device and come on a nice lesson with the different devices that they have. We actually did a class where the students were supposed to teach one of these lessons for your own device. So for my teaching activity, what they did was they had asked the children to bring different things, students per se, and they would plan a lesson with the different devices. So even if it's addition, they have to use their, you know, the calculator on the phone or whatever, the tablet, so they were using the devices for different learning. And then the next thing too, one of the things now big in schools, tablets in schools, we have to go and learn the softwares and go and see where the softwares are and get them on the tablets and the smartphones and the laptops and incorporate them in class. Nowadays, we don't have to, I can give you some websites, of course, where you have software. Some of them you might have to pay for, others you can get free. But we have to get a lot of math. GeoGebra is a free one. We need to, GeoGebra. Well, Master's is not really a software, it's a learning website, but even Master's is a good website you can get your students in. So when you use terminology in class and so instead of you telling them sometimes, they can say, go on your phone, look it up. Because I have times in my class when students say, Miss, what does this word mean? And I might know, but you're teaching them something. You're teaching them that you can go and research, you can go and look, you don't have to rely on me, you don't have to ask me everything. So that's a good thing. So we get to us the different softwares, upload them on the things that they have and use it, because the truth is, when we're teaching, they're on it because they're bored. They're techie people, so they're on their different devices. So since they love it so much, we should use that as a learning tool. All right? So what?
Most of the schools, the students and
but we do it in the teachers' colleges because the students have their phone and they'll just run outside and say, Miss, hold on, I can't go outside. Yes, talk on the phone and come back and then tell it another one and just tell it anyhow. That's a different story. So what we try to do is to allow them to use the phone. So we give them research and stuff to do on their phone. So it's okay. So we try to incorporate it rather than just like how it's okay for you to use your phones in here because you can WhatsApp in a question or something, not talking on it, of course. But one of the reasons why we have the WhatsApp group, if you have a question that you need to ask and you don't want to ask or you don't want to disturb or interrupt a conversation or a discussion, you're supposed to be posting your questions, or that's one of the freedom of having WhatsApp, the WhatsApp group. It's the technology. Because the truth is, before we move on to the next thing, as I said, we're actually early, the truth is, as teachers, we cannot be left behind. If we look at what the countries like Finland, I think the mother countries, Finland and Singapore, what they're doing in terms of math, the teachers have to go out there and learn how to use the different technologies to teach in their class. So we have to go out there and figure out how to use it. This was not the course that was designed for that, but I'm just sending the information out to you so you can go and start with the research. Because the thing is we have to know about things that we can do so we can research. You know, we have to be aware. All right, everybody? Are you guys with me?
Yes, we are.
All right, do you agree with what I've said so far?
Yes,
We do.
Okay, have you ever tried planning a lesson where you have your students incorporate any form of technology?
yes.
Okay, who is that? Who is that? Who answered yes?
I have tried it, but not so in depth as in making them do stuff. Most times it's to have them just go and learn stuff on YouTube. Sometimes like to see a different explanation for a topic or something. Because sometimes you explain something very simple to them. Well, you think it's simple, but they don't get what you're saying. And maybe if they hear it from somebody else, then they realize, this is what Miss was saying all along and so on. So sometimes I have them just use, because they were given laptops by the St. Lucian government. So I have them use it sometimes.
Okay, that's very good.
Could you adjust the camera again, please?
All right. Okay, I'll do just that right now. Can we adjust the camera, please? Jeffrey, that's a very important point you've made, because one of the things that we need to do is to ensure that our students know that it's not okay anymore to complain that Miss Teacher didn't understand. It's not okay anymore because the access to information. So they can go on YouTube and Google and learn, so that idea of becoming independent learners, we need to say, all right, you don't understand, go on YouTube, look at so-and-so, and tell me what you get. Explain to me in your own words what you get from that. So that's a good idea, because as I said before, we're teaching them how to be independent.
You need to bring the camera up a bit. Go again to the right. Okay, perfect.
All right, so I'm just giving you some topics here on the board. What I want you to do is to write the concepts. These are things that we've covered in class. I want you to write the concepts, or the concept for each, or what, because some of, I don't think some things have more than one concept. But write a concept for each, and then write a teaching approach. This is a quick revision of what we've been doing, some of what we've been doing over there.
We are not seeing the topic column though.
Okay, I have sets, reflection, factorization, mean, inverse of a function, circle theorem, bearings.
Struggle, man.
Have to push it off.
Yes, we have to say yes.
It's going to be too much trouble. I can do that. Thank you.
Is it working, guys? Everybody? Guys online, are you still there?
Working.
Okay. No.
Thank you. I don't know what's for.
What did you say?
No.
Oh, she was just saying yes, that knowledge.
Better than some.
Is he this one?
Okay, finish working now? Me supplying the answer? Guys, can you hear me, online students?
Yes, we can
Yes,
hear
Mr.
you.
Which
You
one?
can go ahead. You can go ahead.
Okay, I kind of like have to go ahead because I have to go on here. As you notice, you guys haven't gotten a break either. All right, so I just want to finish up so we can all go. I don't want us to stop taking a break. All right, the first thing is sets. What did you have for sets? What do you have for the concept of sets? And I'm not telling you any answers. Mona, that's specifically for Mona.
Is that discrimination?
Discrimination, okay, discrimination, but I belong to Mona too. That's specifically, no, I'm not telling Mona students any answers.
It sets means that's a collection of things and they can have like similar characteristics.
All right, that's what we have for the concept, everybody?
Yes.
It's a collection of things with similar characteristics. And what's the teaching approach? What did you do? How did you bring across this concept?
Use children in the classroom with pens and pencils and black ink for gluing, writing. That's the whole, that's the union there.
Mm-hmm.
And for all of those 20 students, 5 of them, they have reading, 2 have gluing, 3 of them, no, I'm just saying, 7, 13. 13 has black and blue. So 13, that's the one where they intersect. That's all of them having the same color right there, black and blue. Right. I think it through. But
all right, good try.
I use pens
good.
and pencils in the classroom. So
anybody else?
Don't bring anything.
Anything different? All right, that's it. Reflection. What do we have for reflection? So I'm starting with online now. Anybody? Somebody? Are we just tired? Diane? Zana? Anya? Caroline? Tasha? Jeffer? Where are you?
Okay, I have.
I'm here.
Okay. So what do you have for reflection? Nothing?
I have each point of the original figure has an image with the same distance from the line. I wrote it very small on my page, so I'm reading. Of reflection as the original point, but is on the opposite side. That's what I have.
Okay. Anybody else?
I think we would add the mirror line to
what?
it as well as a concept.
Caroline, all right. Anybody else? Mona? What is the teaching approach there? What's a possible teaching approach here for reflection? Guys, remember this is like revision.
Could you use examples such as the pictures, real life pictures, or the students and mirrors in the classroom to get them to see themselves on the opposite end?
Okay. Good. Do you know this activity where you draw half of a face and have it on a paper and allow the students to draw the other half? Okay. Just use that.
Yes.
It doesn't have to be perfect. All right, so you can have that, even to introduce it, just have half of the face drawn and then ask them to, yes, and ask them to draw the other half. All right, yes. All right, factorization. And remember, these are, I'm just bring back your memory focus for the test.
It's like writing an expression.
I'm not saying these are what's
writing an expression as a factor of its products. The product of its product.
Right, okay. Anything else?
Its factors, yeah. That's
anything else? What's the teaching approach? I'm not even going to linger with you people. You know? I'm just going back through. I'm not lingering. What's the teaching approach?
The algebraic tiles.
All right. So you use the algebra tiles. Okay.
To let them form a rectangle.
Very good.
With the tiles used to represent the expression to be factorized.
All right, and then now you have to remember to say what? What is missing? The factors are the what? The length and the width.
The length and the width, yes.
Oh, they should come on here, so. All right, what about mean? What's the concept there? You see, we do these things in class now?
That was me for that one, but apart from that,
What about the mean?
The mean is one number to one value to represent a data set, or it's sharing a set into equal sharing a set of items equally. Sorry.
Good job. You saved the Mola students. I was just about to put them on punishment, you know. I was just about to put them in the dark corner. All right. What's the teaching approach there?
You can give them a bag of items and have them, let's say you choose 3 students and have them share the sweets or whatever items among themselves, like I did with my activity for the presentation last year.
Because even her teaching, you remember her lesson? No, you weren't here. Okay, all right. Try and get all those things. All right. What about inverse of a function?
It's the reverse of the original function, or the opposite.
Yes, it's
finding the domain given the range. An expression used to, because you get an expression from domain to range, so now you need an expression to find the domain given the range.
All right, so it's only, you say it's only the students online. Did you learn something?
yeah.
You're right? All right. Okay, so let's look at what did we do?
Oh, we're nervous.
You're nervous?
That's why they talk so much.
All right, so what's the teaching approach? What teaching approach did we use?
Give them the original function and show them that all we're doing is the opposite of what we did.
Very good.
So if you had like 2x plus 5, you'd show them it wouldn't be 2x plus 5, it would be x minus 5 divided by 2.
Good job. Very good. All right, what about second theorem?
Properties of angles and circles.
Yes. Our circle facts, or we want to put it good, very good.
Oh, because I was wondering if there's actually a concept. Okay, circle facts, all right.
Yeah.
You can use the geoboard like we did.
Yes.
Have them demonstrate the different circle theorems, use their protractor to measure the angles and so on to prove things like the cyclical, quadrilateral, and so on.
Very good. Good job. I see that some persons are actually ready for the test.
That's all the three?
Parents, you know, it's a little bit more than that, but it's basically if you have these things pat, you should be ready. So just go through all the things that we've done and ensure that you understand the concepts and the teaching approach, and then you should be ready. Parents, I cannot tell you what this thing, I hope you know earlier, I can't tell you the topic.
Measures direction or angle of movement.
So it's only one A student having my class. What time to do?
Only one is student.
All right, so what's the teaching approach?
We can use what Anya said earlier, or we can use 2 students, or the map as well. We can put points on a map and have them estimate the angles and so on.
Yeah, very good. All right, that's it, folks. Goodbye, Ricardo. We're going home.
I'm just in time.
You're just in time for to go into the door with us. All right, guys. As I explained earlier, I have to leave early today. I'm sorry for that. But anyhow, I feel good because I'm giving you 2 hours to really focus. I know you have other courses doing because I see you talking on my WhatsApp. I'm just kidding. I peek in and saw that you were talking about other assignments. I realize that you have work doing, but you have 2 hours here to prepare for the test. And good luck. I'm sure that you all will be successful.
Thank you.
Thank you.
Take mark in our papers. Trust me, ours, we not write that up. Jeffrey, can you just,
What happened? Dana?
From email of all you have.
I actually wrote it on a paper so small there.
Miss McArthy?
Yes, was it Sabina?
Yes. That's Sabina.
Yes, Sabina.
Yeah, my video. I just wanted to say that it was good having you to teach us that course, and I was glad that you taught us 2 of them. And yeah, it was really good having you for that course, and you did a very good job with that 5-hour class online.
Oh, thank you so much. You're too nice. Thank you, guys. And trust me, I really love this group. And I'm not just saying it, but I really enjoy teaching you guys. And even to be honest, even more now. And to be honest, I think I got a very smart match, and smart as I've seen so far. Yes. You see, guys, you know what is happening here? They think that I prefer the online students, they think that you guys are brighter. It's where we going. But, all right, but you guys were a very smart batch, and I really enjoyed it. And I know that you guys will do very well on the test because you did very well in the last course, very, very well. So I think I have a lot of A's that I need to kind of defend in the last course. So. All right, all right.
Thank you, Miss McArthy. It was really nice, like Sabina said.
Yes.
You were not bored.
I enjoyed.
Thank you.
I enjoyed the course.
We got 2 good days out of every week.
Yes, baby.
Jeffrey, you back him up.
All right, guys. So I'll see you. I have to go now. I'll see you on Thursday. Please remember to be present for your test. I don't think
you won't see us, Miss McArthy, will you?
I won't see you guys. This is the last class. But please, we will still talk on WhatsApp. Please keep in touch. All right? We'll still talk on WhatsApp. Okay?
Copy.
Okay, bye-bye.
Okay, thank you, Miss McArthy. Bye.
Bye.
Bye, Jeffro.
Thursday. Toodles.
Bye, everyone. Bye, Davey.
Bye, guys.
Everyone.
Ingrid, is Ricardo there?
Yeah, good luck.
Just came in.
Okay, well, bye, Ricardo.
He's coming to make sure that you see him. Ricky, step up, man. Ricky's coming, don't leave yet.